Okay, let's move on. So by now you should be able to configure your front end and Condor, everything should be up and running. Few more words about how to fine-tune your Condor configuration. And let's start with regulating user priorities. So you have your Condor pool, it works nice and dandy, but by default, the negotiator will treat all users equally. So you get essentially the fair share out of the box. If you have, for example, 2 users, each will have on average half of the resources. But you may have different needs. And the negotiator supports things. It supports priority factors and it supports accounting rules. The priority factors essentially reduces the priority of users. So if you have 2 users and the first user has twice the priority of the second one will get a third, the other will get 2/3 of the slots. So it's, if you x gets priority factor that is n minus 1 times the priority factor is y, x gets 1n of the slots and y gets n minus 1 divided 10. And the other one is the accounting rules, and it's too big to fit in together with the others, so here's the dedicated slide. So users can be joined in the accounting groups, and you should know that the negotiator defined the group, but the jobs themselves specify which group they belong to. You cannot really centrally set that. Each group can have a quota, and should have a quota, and can be relative to the size of the pool or can be fixed. In the case of gliders, you really want it to be relative. And the sum of all group jobs cannot exceed it. So essentially, if you have, you say, half of all my glidings should go to group Higgs, the Higgs jobs will never exceed half of that. There is enough to say, yeah, you can actually exceed it, but by default, you'll be fixed. Once you hit the limit, you're done. A nice property is that you can have quotas that are more, the sum of all the quotas that is above 100%. And the higher is better. So if you have quotas for Higgs and a quota for, let's say, B physics, and you set it 300 and 200, one will get 4/5 of, no, 2/5 of all the resources, the other will get 3/5 of all the resources. So this way you can actually set relative priorities without limiting the number of jobs that can run, especially in the gliding pool where things just grow. You never want to have quotas that are below 100%. If a gliding is started, you want it to actually run something. So how do you configure the accounting groups? Well, you essentially just need it. That's all it is. And then, again, jobs will need to decide by themselves which group they belong to. Which gets us to this point, how the job decided. Well, it adds a line like this. It says, my accounting group is group Higgs, and I'm user Frida inside the group. And it's on the base of trust. There is no automatic mapping, no enforcing. You just have to trust the users. You have thought if you want to ask why it's like that, but this is what's on the ground. And it works nicely for portal-based systems. I don't know how people with interactive use do it. That's what's available. So this is how we do it. Nice and easy. The other part, we said Condor supports priority factors. I told you what they are. Now, how you set them. Usually, so to set them, you essentially have this command called the Condor user prior, and the negotiator maintains the priority factors of all the users internally in memory. It's persistent, so it stays within. It will survive reboots, but it's really just a memory presentation, everything gets properly on the disk in the track pattern. So if you run user prior minus all users, you get something like this. And here's the one user that has certain amount of, that's his priority, and this is the priority factor. I think I have something later on, more details, but that's pretty much how it is. And if you want to set the priority factor, you just call it minus set factor, name of the user, and the new priority factor. Now you see, run it again, and it went from 10 to 1000, and I think I underrated this file because it should have been 80, it should be 8000. I should fix it. Yeah, this and this should be this.
What is node 1 there? Node 1 is the mid node?
Yeah, this is essentially your UID domain. And it depends how you configure it.
Okay.
Different things, but by default is the name of the node. So
Submit.
submit by default. Yeah. You can change it in the configuration. Yeah. By default, it's the full host name. Another nice trick is to set the default priority factor. If you don't set it, the default is 1, and you cannot lower it. This is you cannot go below 1. So if you want to, so you can only penalize users. You cannot have users that are better than default. So when you install the Condor pool, it's a good idea to set the default priority factor of, let's say, 1000. So everybody starts with 1000. And so if you want to give somebody 1,000 times better priority, you lower this to 1. If you start with 1, there is no way to make somebody with more priority than 1. But you can only make them worse. So starting with a high number, it's a good idea. So you can go both directions, not just one. And that's a link with more details if you want the menu. And all I have to say about the the priorities, there are more details, but I don't think anybody will need more than that. And if you do between the Condor team or ask me, they can explain the glorious details of what's available. Now, we can also tweak a little bit how the negotiator matchmaking cycle works. So, for starters, how it actually works. So the negotiator gets all the machine ads, and then gets job class ads from all the sketties one by one, prioritized by user, and then does the magic and tell the sketti if they match. Then sleep and repeat. And does this continuously. To the first approximation, of course, there's more to it. Is the first thing. Now, being in polling time, it has sleep between cycles in order to save some CPU. But Condor has the nice property that every time a new job is submitted, a new negotiation cycle is triggered. So even if the sleep was high, you would still get a matchmaking cycle started when a new job is submitted. Unfortunately, they don't have an equivalent for when a new started joins the pool, which is the case of the glidins. So when a new glidin starts up, it doesn't trigger a new glidin cycle. You have to wait the whole sleep cycle before the glidin is even considered for matchmaking. That makes perfect sense for a static pool, but in the glidins, it's not really a good idea. So you should keep that sleep as slow as possible unless Condor team eventually changes that. And this is set by the negotiator interval. And if you use the glideinWMS installer, it sets it to a minute, which it's reasonably low and still keeps the CPUs not too busy. You can set it to a second if you want, if that machine is not doing anything else.
It'll self-limit itself to 15 or 20 seconds, right? You set it to 0. It'll still sleep.
Yeah, it doesn't want you to go below 20 seconds.
But since the negotiator, a lot of it is single, or unless you put some magic to it, it's serial and single-threaded. You know, in this day and age, I just set it to the lowest value possible because I don't need to save CPU on an 8-core box.
It depends if that node does anything else.
Yeah, but people have 8, 16, 32 cores still until
Yeah.
this goes totally multi-threaded, multi-processors.
Yeah, I mean, there's no
You're not
big downside to setting it. Well, it won't let you go below 20 seconds though, and the reason for that isn't to save CPU, it's because the matchmaker is more or less stateless about what matches it made in the previous negotiation cycle. So that allows, it hands all the matches out, and then at the start of the next negotiation cycle, it grabs the class adds, and it wants time, there needs to be a little bit of time so that the decisions it made in the last negotiation cycle get propagated back to the collector, so that it's, making its next round of decisions, taking into account what it decided 20 seconds ago.
So I have to modify the slide. Another thing to consider is preemption. By default, Condor will preempt the user as soon as a job with the higher priority, or from a higher priority user is available to approximation. But any preemption is wasted CPU because preemption is here to kill the job so that the new job can start. If you use the glideinWMS installer, it will disable preemption. Essentially, setting it in such a way that once a gliding is given to a user, you will give it for the lifetime of the glider. So, out of the box, if you use the installer, preemption is completely disabled, and essentially all fair share is broken on the gliding. Once the gliding gets its hands on the user gets its hands on the gliding, it keeps it. The reasoning before for this is essentially gliding is a limited lifetime resource. So after a while, it will go away anyhow. So let's optimize the use as much as we can. And so once it's given to a certain user, it can use it until the lease of the gliding expires and you go away. This screws up a little bit the fair share in the short term, but over long enough periods, it just works fine.
By user, you really mean job.
No, user. A user.
Tied to any user.
A final user. Look, some US Filigoid has submitted 1,000 jobs on your schedule. This is the user that will be matched initially to the gliding and will be allowed to keep it for the lifetime of the gliding, even if a user John, which is 10 times the priority, will show up 10 seconds later.
Good to know. Not what I expected.
We have, right. It's a configuration variable, and this is what we do. And essentially, you can disable it and change it. But this way, it's the most effective way, even if it screws short-term priorities.
Yeah, this is, Steve, you can configure your Condor pool here to look whatever works for you.
Yeah, no, I'm just thinking of, to me, all of our users have the same priority, so it's not a priority thing. It's just the way I envision it. Well, I didn't know it's out there. It's treated first come, first served like the other nodes.
It will the first time.
But
Right,
only the first time. So
yeah, and then for the rest of the lifetime of the gliding, we keep the same user.
So, okay.
And
That's fine.
yeah, you can disable that, but it actually makes every time a gliding decides, oh, I want to see who is the higher priority user. It has to go through the negotiation cycle. It has to go to the negotiator. Negotiator has essentially it can declare itself empty. Go to the negotiation cycle to find the user to start it. If you fix it to a single user, the negotiator doesn't even consider that machine anymore because it will never unclaim. So it will always be defined as in use. If you remember yesterday, the negotiation cycle, it's negotiated and then the claim is established between the SCED and the start date. And that claim can be reused as many times as needed by sending one job after the other.
Right.
So what we do by default, we say the claim is essentially timeless. It's forever, instead of saying it's just for one job.
Okay, so I'll ask the other question. So, the user put in a job, got a glide in now belongs to the user.
Mm-hmm.
When user runs out of jobs, what happens?
The claim is,
Terminated, or does it go to the next user?
it gets to the next user.
Okay.
It's essentially, the claim is broken because the schedule doesn't have anything of that user anymore. The negotiator will see it's unclaimed, and a new claim will be established.
I mean, you can change it if you want to set it up so that you preempt, you know,
No, I don't want to preempt.
you can also set it up so that,
Just shuffle.
yeah, you could also set it up to quote unquote preempt the claim, give the machine from one user to a different user, but only at job boundaries. So you could tell Condor, wait until the current user's job exits of its own accord, and then consider giving the machine to a higher priority person.
You will just waste about a minute or two between jobs because it has to go to the negotiation cycle. So,
See, I learned something.
yeah, this is why you're here,
Exactly.
hopefully. So that's settled. The other thing you want to set the negotiator is to protect against dead glidings, or at least remove damage from dead glidings. So glidings can die. It's just a fact of life in dread. Sometimes the gliding will just, boom, die into nowhere for whatever reason. But the class sets will still stay in the collector for about 20 minutes because there is no permanent, persistent connection between the gliding and the collector. It's just periodic updates, and the collector will get rid of them only if they didn't update the classes for 3 times in a row, which is about 20 minutes. So, if the gliding dies while it was in unclaimed idle state, the negotiator will match it. So, the negotiator will try to send jobs to that gliding, and of course, it will give the highest priority jobs to those. So if you imagine how happy are the highest priority users if you start sending them to that glidings. So in order not to get into that, the installer will put a line like this in the negotiator matchmaking, which says, when you get the list of all the machine ads, which are the glidings, order them on the last time they advertised. So the dead glidings will be down in the bottom because you haven't heard them in a while, and the fresh glidings will be matched first, and only the low priority users will try to go to the dead glidings. Yes?
Do you have any feel for what are the leading causes of just completely dead?
Preemption, mostly. Preemption on the grid. Some sites are just preemption happy, sometimes we just screw up and we exceed some limit, too much memory.
And when they preempt you, they just kill you hard, kill -9 hard.
Pretty much, most of the time.
No different.
Yeah. You usually don't have the time to react, although sometimes you may.
What does it happen to the job matched to the,
Of course it does.
the job
yeah,
dies?
Yeah, it will that and it will be rematched somewhere else.
I reveal.
Like anytime the client goes away, there is a lease between the skip D and the start date. If the start date goes away after, I think the default is 20 minutes, it will say, oh, the job is likely dead, LMAP is dead, and I rematch it to the next available client.
So it will be restarted.
Yeah, it's essentially the start.
Okay.
Essentially the client says, the start skip D says, I have no clue what happened to it. I'm assuming it's dead. Let's start it somewhere else. The other part of the equation is protecting against slow SCADs. So if you have a single SCAD, it's not a big deal. But if you have more than one submit node, one will be faster, one will be slower. And the slow one may be because you have interactive users that are completely swapping the machine. So that SCAD is doing one operations every 2 minutes instead of doing 2 minutes. In that case, you don't want the negotiator to be stuck on that slow SCAD and ignore the rest of them. This was really important before the 7.6 or whatever series is. It would actually kill your negotiator. It's much better right now. So it's not that big of a problem, but it's still a good thing to do. And there are 2 variables that you can set: negotiation max time per submit and negotiation max time by spin, if you really want to know what this means, follow the Condor manual. But this is what the installer will put in for you, and you can research why in a little more details in the Condor manual. It's just essentially emergency brake. If you exceed that, that's something wrong. Another thing that it's good practice in the gliding pool is disabling one feature that the negotiator usually do. And when the negotiator makes a match, by default it will send the match both to the start D and the scale D. And that's not really necessary. As long as you send it to the scale D, everything will still work. And the other one is for whatever reasons they decided, but it's completely optional. And when you have fixed behind firewalls and do all the magic of CCP and so on, it's a huge overhead. So just disable it. So in the negotiator will put this line in it, essentially say, just use the straight minimum and don't try to be too smart for your own good. And yeah, so you know why that line is in your configuration file if you install it with installer. That's all that is for really for negotiator. Let's see what we do usually for the collector. Most of what I'm describing you get automatically if you do it in the installer, so you know why it is there. So the major tuning is the collector tree. You need it. Without it, nothing will work. Not past a few hundred gliders. And we've already discussed this in detail, so I will not go to it anymore. But there are two optional settings that you might consider for your gliding pool. The first is the security session lifetime. In GSI, so in gliding everything is GSI based, right? You said because of the wide area network connectivity, you want end-to-end security. You use GSI for that. But GSI handshakes are really expensive. It can take a few seconds for it to be established. So Condor only really uses it the first time to process a stock, to exchange a shared secret, and then it uses that shared secret from that point on. But this shared secret actually has a lifetime, and you can set it high or low depending on if you want to optimize for speed or you want to optimize for security. So you probably want something in between. The default lifetime used to be really long in Condor, something like a few months, which was ridiculously high. It was very optimal for speed reasons, but it was not very secure and actually screwed up the collector after a while because of all the caching. So installer will limit it to 12 hours, and I think that the recent versions have it to 24 hours, so it's not really that important anymore. But we still put it in so you know why it is there, and if you are more paranoid, you can lower it even more.
That's in theory the best default would be to make the session key lifetime the same as the GSI proxy.
Or close to, yeah. You may want it to be a little shorter, because the lifetime of the glide is shorter. If anybody intercepted it anywhere or crashed your collector or whatever. But yeah, you definitely don't want it to be longer than the lifetime of the proxy. This is optional. You don't need to, but remember we said the collectors work as CCBs, and we use five descriptors for each and every gliding. 5 plus, between 5 and 6. And by default, the operating system usually give only 1,000 file descriptors for each and every one of them. So Condor itself, around 80% I think, will start refusing new connections for self-preservation, so it can do really important stuff with the remaining file descriptors. You may want to increase this limit so you can serve more glidings with a single CCP and until double root. And you usually don't run this route, but you can do it. Although I don't really recommend it, I think it's better to just have more secondary collectors so you also spread the CPU better. But if you are not a fan of having many processes, you can have fewer processes with the higher fiber skip count. And on top of that, make sure you don't round off system-wide limits. Some installations come with quite low limits in the tens of thousands, and even more than that. In a big pool, you need hundreds of thousands. So make sure you actually raise that limit if it is low. So another thing you have to be aware of is that the collector is actually answering all the clients that are asking for classes. This includes both the negotiator, but more importantly, all the Condor statuses the users will do. And every time somebody does Condor status, well, there is a lot of processing going on. In order to not, and yeah, it's getting even worse than that when you do Condor Q minus name, the name of the SCID from remote. It will first interrogate the SCID and then the collector and then the SCID. And both of these commands are used by the front end, so you get a lot of hits against the collector just from the front end. Never mind anything that users can do or your portal is doing. Now, since the collector is a busy process, they have added options to actually fork the moment a query comes in, so that the fork process actually answers the query while the collector continues to do its own job. So whatever was the status of the collector at the time to do the fork, it will be sent back. Which makes a lot of sense. The problem is that this may use up a lot of RAM. Now, the fork uses the system write on change properties. However, an active collector will essentially sweep through all of its memory in a matter of minutes. So if the query is complex enough, you will essentially double the memory use of the collector for each fork you have. So be aware of that when you plan how much memory you need. And the default for the collector query workers is 16. You'll have at most 17 collectors, the main one plus 16 others. And this may need to be tweaked. If you're really short of memory, you can drastically lower it. Better to slow down the collector than to start swapping. If you have plenty of memory, you may actually want to raise it so you protect against users doing 4 Condor states and doing it in 10 different sessions at the same time. A few words about firewalls. I mentioned it yesterday, I want to stress it again. If you have decided that you want to keep the firewall, you need to tune it. As a straight minimum, you need to open the ports for the collector trees, because this is how all the glidings will talk to the collector, and they must be open to pretty much everyone under the sun. You cannot put any restrictions because the glidings can really run pretty much anywhere, unless you really want to micromanage where the glidings can run, and that could be a mess. But you will possibly also need to open it for the negotiator if your firewall is really specific to the node and your SCIDs and clients are outside that node, which likely will be. And a small problem with that is that the negotiator port is usually dynamic. So if you really want to keep control of what is open, you want to open everything about 1024. You should run about 1024. you need to fix the port it will run on. And I think 9617 is a nice number, just below the collector port. And this way, it will always start on this port, and you can open just this single port in the firewall. Now, you still have the problem of hundreds of thousands of sockets being open against the collectors. As I said, 5+ for each glide-in. Depends how big your pool is, but you may get in the hundreds of thousands very, very fast. You may need to tune what's going on. And here are a few suggestions for the Iptables. The default one will just die, essentially, if you try to use it for anything that is not trivial. If you use anything that is not Iptables, you use whatever that firewall uses. But be aware that there will be a lot of TCP tracking going on. And unless you have good reasons to keep the firewall on, I would just turn it off.
Yeah, I highly recommend you taking the firewall off because it's not doing much useful activity. You're sending so much network activity in and out.
Unless
Or
you
at
have other processes that you really want to firewall. But
Or for a busy pool, you may not. And at the very least, then maybe shut off connection tracking if you can do it properly. 'Cause I don't know if we have any cases where I guess we've successfully tuned that number up on some very busy pools, but in the end, the recommendation was, and they did this at CERN and just shut off connection tracking.
yeah, I think they did it in the end.
Well, I thought they did. Should.
This is all I have for the collector. Now a few words about the schedule. You see it's not that different, although there are a few more things you want to do. So these are the knobs I would recommend. Job limits, start, termination limits, client handling limits, measured attributes, requirements, defaults, and periodic expression. And the system settings, which will be similar to the other ones. So for the job limits, as I said, the main resource limit of subit node are the shadows. Each shadow will use about a meg of RAM every time a job is started. So if you don't have infinite amount of memory, which you probably don't, you would probably want to limit how many gliders you start most. And this is how you start it. It's not job running. I know in the past that was set to a ridiculously low number, like 200, and you had to change it. I think in newer versions of Condor it's much higher, so you don't have to change it.
Condor, it's not throttled.
It's not throttled at all.
I don't think so. I think
You would remove this at all completely?
it defaults to 0, which means no limit.
Oh yeah, but if you set it, it will still be throttled.
Absolutely. Oh, does it? That's even better.
Okay, so maybe for the newer ones it's not necessary, but it may still be a good protection for you essentially to say, I have 8 gigs of memory. Let's not run more than, I don't know, 5,000 jobs because it's likely that my machine will die. Better to have idle glidings if I ever go above 5,000 glidings than completely kill everything. And this is how we set it. And the installer will fix it to 6,000, which is pretty high, but reasonable for most recent hardware. And most smaller VOs never reach that limit anyhow. Whoever is bigger should raise it drastically. You may also want to tweak the startup limits. Each time a job is started, the schedule must create a shadow, the shadow must load the input files from this, and the shadow must transfer the files over the net. So it's not negligible, the amount of work it is to do. If you start too many at once, you may overload the node. So you can actually throttle that using 2 kinds of knobs. One is job start delay, and job start count, and the other one is max concurrent upload. The first one is what the name says, how fast to actually start them. The second one instead regulates how much file transfers you have. This is discrete and it's pretty predictable. this really depends on how big the input sandboxes are. So the two don't necessarily often go hand in hand with a fixed formula. It really depends if you're transferring gigabytes of files out or tens of bytes.
I was going to ask you, max concurrent uploads, is that a size limit or an amount or number limit? in
Number
terms of-
limit.
Number. in terms
How
of-
many transfers go in parallel?
Oh, okay.
And just go to those links to get the detailed. I don't know if you're aware, but terminations can be as problematic, or even more. Especially the output files, because while in the input files you sort of have an idea how much data will be transferred, because you just look at the jobs in the queue and see how big the input files are. Output files, whatever the jobs produce on the worker node. And we have had in CMS users that screwed up and delivered back something like 30 gigs per job, which was essentially killed our submit. No. You were sort of protected against them with same equivalent knobs. How many jobs you want to start in concurrently, and how many concurrent transfers you want back. And for anything that exceeds that, essentially the jobs will wait on the worker node until there is a slot available to actually transfer it back. So you're wasting CPU on the glidines, but at least you are not killing your submit machine, which is worse. The other problem of the termination is when you use glexec and you decide to remove a few thousands of running jobs at the same time, and they are all running at the same site. Typically, glexec is configured to talk to the side gums. So if you kill, let's say, 1,000 jobs at the same time within a second, there will be 1,000 glexecs from 1,000 nodes that all try to talk to the side gums. And you're likely to make the life of the site admin miserable. So you should set this something that is not that fast, so that when you actually remove the glidines, they go away slow. Not too slow because you're wasting CPU, but slow enough so that you don't overload the site's resources. You may not care the two times, but the third time you may be banned. So it's in your best interest. Just like with the collector, the SCARED must handle Condor queues. And it will do the same thing. It will fork on query. Because the SCARED is also a very busy daemon, actually often way more busy than the collector. And again, side effect of that is that it will use RAM, because again, it's right on a change, but Condor tends to spread its memory pages all over the place, so it changes pages very, very fast. I think you want to kill this because the default is ridiculously low. It's set only to 3. And this is probably too low even just to handle the front end if you have any interactive users. So raise this to 10, 15, 20. Depending how much RAM you have. You will have to fit it in the RAM you have available. Now, you may want to know where your jobs are running. So when you have a dedicated pool of resources, yeah, your job ran, you don't really care where it ran. But in the grid, especially if you are like CMS and run on 150 sites, you may want to know where it ran because something may go wrong, or you get weird side effects because you ran at X instead of Y. By default, you get last remote host in your job class app after it is matched. And you can look it up and see where it ran. But this will only tell you the name of the worker node, which may or may not tell you which site it was, especially if they use a net and it's called like node1.local. So you may want to know which site, which factory, which entry it came from. And it's relatively easy to add. You just need to add the jobs in the job submitter, job attribute equal $$ and the gliding attribute name. And after the job is matched, you will get an attribute called match expression job attribute that has the actual value of where it matched to. But you can do it even better. And instead of asking user to do it, you do it centrally in the SCAD config. And I'm not sure if the installer does it for you, but if it doesn't, you definitely want to do this. And this is just a bunch of things you want to add. Essentially, the factory identification, the glide identification, your own front-end identification, in case you have more than one front-end. Any other attribute you are interested in regarding that specific gliding, for example, site, but could be anything else. How much memory was available? And then you need to add it to the submit expressions, which essentially says put it in every single job class R for every job that is submitted on this machine. And yeah, just do a Condor status on any gliding and see what is there and decide what of this that is interesting to put in. Definitely recommend these ones, the factory identification, the gliding identification. So if anything goes wrong, you can actually give this information to the factory admins so that they can try to debug and look in the proper logs to find out why the heck my gliding is misbehaving. Everything else is for you. There are other things that you may put in the SCAD config that changes the default behavior of user jobs. And the first one is, as I stressed several times, you want an empty job requirement. So you want, ideally, you want all the requirements to be set in the glidings and nothing in the user job. So users should not set anything. Unfortunately, if they don't do anything, Condor will still do something. It's just too smart for its own good. And it will forcibly put in architecture, disk, and memory requirements that are just standard based on what the machine is where you start out. So just disable it. So if you put something like this in the configuration, this will be actually the requirements of job head, which evaluates true pretty much. It's pretty much guaranteed to be evaluated true. It will not have any other default settings that Condor would put in else. So essentially outsmart the Condor by disabling all the smartness it has. And it's your best interest, especially in the uniform gliding world. So you don't care about arch, disk, memory. If you really need to do something, it's better do it in the gliding itself. Another thing that's useful to add at the system level is the various periodic expressions. Because you will likely have users that are not 100% well behaved. Sometimes they will screw something up. And you want to detect them and remove them from the system as soon as possible. Because they're misbehaving. Whatever they do, it's a waste. You have two different things you can do. The periodic remove and the periodic hold. The difference between the two is that the periodic remove will just remove it from the queue. So after it ran, you do control queue, it's not there anymore. Periodic hold will actually hold it on hold, which means in control queues will see it, but it will not be used, it will not be considered in matchmaking. So they will never start. It will just stay in the queue forever unless you decide to remove them. They can be arbitrary Boolean expression using any attributes you want. And which one you prefer is up to you. This one stays in the Condor queue, so you can look how many have been held in the past month, day, or whatever before removing them. This will have, you will have to go after with Condor history, which is much slower. So if you ever want to see why they were removed, periodic hold is probably better, and they have an independent step that actually removes them, so that you actually see why they were held. But that's a matter of taste. The end result is pretty much the same. And here we have a few examples of what you can do. Here you can define a system periodic hold, and it said if job exceeds 2 gigs or of memory, or have used more than 10 gigs of this, or it's running and has been running for more than 100,000 seconds, or can be restarted 5 times, just get rid of it. It's just pathologic. This will never run to completion. So put it on hold, and it will not be matched, and you can remove it later on. If you use the latest 77X series, you can actually add a hold reason too. So by default, if you don't have a hold reason, the hold reason would be the job was put to hold because this expression evaluated to true. Very useful. Instead, with 77X, you can actually add something like this, where you have if then else, image exceeded. Oh, it used too much memory. This is why I put it on hold. Blah blah blah. Job count is more than 5. Oh, I tried it too many times. And if it's anything else, for whatever reason, you just say reason or no. So you actually make it user-friendly for the users, so that when users do Condor human is held, they actually know why it was held, not the periodic expression is evaluated true. Yes, thank you. And here is the links on a little more details of what can be done. Similar constraints with concerns about file descriptors as in the collector, but in this case it's not per process, but system-wide. Each shadow will keep about 10 file descriptors open, which means you have to have 10 times number of running job file descriptors available, and you may not have them in enough system-wide file descriptors available. So make sure that if it is not, just raise them, and here's an example how you do it. Any Linux sysadmin should know how to do that anyhow. That's just a quick reminder. Exactly the same slide as before, with the only change is that the only port that really needs to be open is the shared team port. If you use that, you really should. But again, you may run into problems with scalability of the SCADs. And if at all possible, and you know what's running, if you have interactive users, you may think twice about dropping the firewall. But if you have a portal, when you know what is running on that machine, I would drop it. Else, be prepared to tune it, tweak it, debug it. Yeah, firewalls will be stressed. And this is all I have about Condor.